But on the other side, that how I know how to turn the wheel, that's a whole nother study that I have to stick with because that's what's got me here. It's my meat and potatoes here. So with having a rotary gap on the bottom that makes the motor synchronized so it knows when to fire, I want to take that and have the wheel run with the PMHs, and I want to go ahead and build a capacitor bank, which is here. The big capacitor will take the charge coming from the energy I create from the wheel. It stores the energy and never lets it go. I just showed you here, and I'll do it again in a quick demonstration. I'm at 2.4 volts. Let me zero it out. I'll show you. Look, I just touched it all together, so it's zeroed out. Okay, bam. Now I'm going to touch this, and you can see the voltage, I hope, right? So you can see it climb. Look, it's 30, 60. So I'm increasing the 12 volts incrementally, and I'm storing the power. That's what I'm trying to show you guys. Look, I'm already at 70. Let's see. I haven't brought it up past 80 something, so this is kind of new area. And I just don't like feeling the snap at the bottom. But I guess I'm up to 90. Let's see, it goes to 100. Whereas 90 are breaking point. Here we go, 100 volts. Dropping. Let's go ahead and snap these together. And you can see the spark there, okay? So anyway, what the plan is here is the capacitors the main capacitor will be being filled from the wheel turning, from the energy created. The small capacitors would be the capacitors that discharge to turn the wheel. So now I'm creating power and discharging. Well, actually, to turn the wheel, forget about that for right now. We'll take this energy and we'll start to charge a battery with it, okay? So we'll look and see, and we'll treat this wheel, like a scale. Part of the scale that's leaning down is the power we're putting in. The other part of the scale is what we can create, okay? Try to get it here. That's everybody's dream, but it's, it's this way right now. So I got to turn it 90 degrees, or work towards turning it 90 degrees. So this is how I'm going to start off. Okay, you guys got to love this. It's two small capacitors off of a high voltage AC transformer into a capacitor here, and this capacitor here is 50 VDC, 6,000 microfarads. Bam. All right, here goes another thing. Christmas lights. We're pulling 34 watts, and we got 0.3 amps. That's what the Christmas lights are using, okay? We got 3 solar cells here. Each one's about a half a volt. So we got 1.5 volts split up 3 ways, going into 2 transistors coming out through a 555. Checking it out. Right now it's running off of just a 100 watt and another 100 watt halogen light. And I'm picking up the voltage with the halogen light. So this right here, pulsating it, I haven't explored yet. I'm getting ready. I just got it set up and just pulsating the cells, using light, using fraction of light, going with mirrors, going with magnifying glass, seeing if I can stretch out the field to produce more amperage versus spreading the field to get more amperage. There's a battle here that I want to look at it in a different way than people have been looking at it, hopefully. But it's definitely through the difference. And if you look at these cells, they're like wafers. They're very delicate. One side here has got some film on it, which is obviously is, one side of the plate, and this is the other side of the plate. Look at the grid. So to me, this is godsend that I got this little kit, because I'm going back to my boy Wilhelm Reich that I read 37 years ago, and it comes down to organic, inorganic material, how they would do their thing, and you can create a cell off organic, inorganic material. So I'm looking at this as a study to get back into Wilhelm Reich and try some studies by building cells by using wood, using stainless steel, using wool, just all different kinds of materials. That means I would have to get into their charge of the materials, the organic tracks, or like our bodies, we're just always consuming, and inorganic is metals, and they're able to have a smaller orbit in themselves and their atom, and they're able to absorb the energy, and they're able to attract the energy. They got mastered both powers, Superman. Anyway, so there you go, and last but not least, 42 degrees in the shed. Wanted to show you, and I got my heater that I designed based off an old one that had blow up on me, wouldn't work. I got the fan sucking, I got the heating element here, and that's it. I got an on and off switch. I'm going to put the thermometer down in the front of it, and we're going to see that 42 climb. It's climbing. I got that there in the middle. I want to touch the elements, but I just got it in front of the elements. So we're putting out some goulash, baby. Some 95 and climbing. 96. Cruising up to a Hyundai. Nice hot air coming out of my supplement. I'm glad I made it last night. Took me about an hour. And right now, 42 degrees in South Florida. Woohoo! NASCAR. I hope you guys liked my long 22-minute video. Basically, hopefully you're on board, guys, man. This is just all knowledge. This is all shelf item. Solar panel stuff in the Wilhelm Reich. I love it. Searle into Ed Leedskalnin wheel. Bam! Look at that son of a bitch. I can imagine it may need one more layer. Oh, and the one thing I didn't mention is the part of Searle I liked is him using square times square or square root. So by using the numbers of magnets and using the circumference I have, I'm going to be using those square root numbers to figure out how many of these cow magnets go on the outside ring, how many go on the inside ring, so we can create that pressure effect on these center magnets. So it makes the wheel want to chase itself with the outsides turning the opposite way. It may need double layers outside, but I'm going, this is what I'm thinking. But anyway, I don't want to get ranted again. Then I gotta say my boy, yeah, Tesla, power to the band. Woohoo! Alright, I think I rambled enough. Doing good though. Not freezing. Got my jammy. Got my dream. Got some studies. Woo! Take it easy, guys. Peace out.